So today we are going to learn about error bars. Okay, so how to find error bars for each of the concentration used. So this by error bar we basically mean standard error. Okay, so the standard error are mostly used in research purposes. Okay, and so to find the standard error we need to find the standard deviation first, right? So in statistics, we must have all learned how to find standard deviation and standard error. So here is this formula that we use in statistics, that is for this population you can see, and for sample, okay, at right side of the Excel sheet. For population, the standard deviation is equal to root over of summation of individual x values minus their average, their complete square divided by total number of population. And for sample, it's root over summation of individual x values minus average, their square divided by n minus 1. Okay, so this is the formula that we generally used when we do standard deviation in statistics, right? So here xi is the individual population value, whereas x bar is the average and n is the total number of sample. And what is the standard error? Standard error is the standard deviation divided by root over of n. So here S is the standard deviation and n is the total number of samples. Okay, so this is the general formula. Now, how to find this bar in Excel? Okay, since it's in Excel, we have formulas that are already present as function. Okay, so we'll use that one in Excel sheet to bring different error bars on the top of the concentration bars. Okay, so let us see with an example. Okay, so here there is an example where you can find this is the drug A, this is the drug B. Okay, so the concentration used are 20, 40, 60, 80 and 100. And R1, R2 and R3 are the replicas of the percentage cell inhibition. Okay, so these are the percentage cell inhibition. Okay, this R1, R2, R3 are the three replicas. As we always do the experiments at least 3 times for confirmation. Okay, so similarly drug B is also done in these concentrations, and R1, R2, R3 are the three replicas of the percentage cell inhibition for drug B. Okay, so this drug A and drug B are used against a bacterial cell concentration, bacterial cells, that is Bacillus subtilis, that is not required. So coming to the standard error, okay, using Excel sheet. So first, for the standard error we need standard deviation, and for standard deviation we need average. Okay, so first we need to find the average. So what we do, we find the average, put an equal to mark here, we'll search for this average function over here, then we select the cells, there are 3, we'll select the 3 cells and press and enter. So this gives the average. Now what we do, we'll drag this one to the last concentration. So it will give the separate average values of these separate concentrations. Okay. Now the standard deviation. Coming to standard deviation, put an equal to mark. Search standard deviation STD. This one is for population and this one is for samples. Okay, so our is the small one. We have taken 3 replicas, so we'll select the sample function. And we'll again select these 3 replicas and press enter. So this gives us the standard deviation. Okay, so the standard deviation, what we do, we drag it till down. Okay, I'll drag it here. So this gives the standard deviation of all the values. Now coming to the square root. So there are 3 samples. What we do, the total number of samples n is equal to 3. Okay, so what we do, we'll just take the root over, that is SQRT, this is the square root. Square root of how many samples? 3. Okay, press and enter. So this is the square root of 3. So drag it down. Since there are 3 replicas in all the concentrations, so the square root of 3 will be same in all the concentrations. Okay, so we have calculated all the data that we required for standard error. Now finally coming to the standard error. What to do? Standard error is the standard deviation divided by this square root of 3. So what we do? We put standard deviation, that is this one, divided by square root of 3. So this gives us the standard error. Okay, standard error of 20 mg per ml concentration. Now we drag this down. So we get the standard error of all the concentration that we have taken in our experiment. Right, so this is how you calculate. Similarly, if you do it for drug B, the process is same. You find the average. Drag it down. Then you go for standard deviation. Take the standard deviation sample. Select the cells. Then again drag it down. Then find the square root of 3, that is the total number of samples. Okay, so drag it down. The total number of samples is 3. Therefore, the square root 3 will be same for all of them. And finally, to the standard error, we do standard deviation divided by square root of 3. This is what we get. We'll drag this down. Okay, so these are the standard errors of drug A and drug B. Now suppose we want to plot this on the graph. Okay, so what we do? We first need to make the graph. Okay, so in order to make the graphs, this average is the final percentage cell inhibition. Okay, this is the average percentage cell inhibition, is the final percentage cell inhibition which we will use to plot the graph. Okay, so what we do, we'll just make another chart. We'll take the concentration here. We'll take the average. Paste it here. This is for drug A. And for drug B, we again select the average, as this is the final percentage cell inhibition, and we paste it here side by side. Okay, to make the graph. Now, okay, so we need to make the graph, right? So you select all these columns, go to insert, go to 2D column, select the first one. Okay, so here you see that this chart is not what we need. Okay, so we need to change the chart type. So you go to the change chart type here. This is column and select the second one. Press OK. Okay, so this is what we get. So this blue one is our drug A and the orange bars are the drug B. Okay, clear? So we need to modify our graph. So I will do it quickly. Put the axis titles horizontally and vertically. Highlight the outline of the axis. Put the axis title. So this is our percentage cell inhibition. And this is our concentration of drugs in mg per ml. Okay, so suppose this is for mg per ml. Now what we do? Okay, now let us change the chart title also so that we do not get confused. So effect of drug A and drug B against Bacillus subtilis, for example. Okay. So what we do, we'll just highlight this one. Okay. Okay. We'll bring the legend to the right side. Okay. So this is what we got. Okay. So now what we need to do is we need to put these error bars on the top of this each of the bar. Okay. Why we need different? So basically when you give the error bars from this plus sign, okay, there's the chart elements, there are error bars. You go to the error bar and put standard error. So you will find that all the bars are having equal amount of standard error. Okay, so the standard error is same in all the cases. Okay, which is not possible, right? So therefore we need to find the error bars separately. We cannot use this error bars that is present in the chart elements, right? So we'll just omit this one. Okay, now we need the standard errors on top of this drug A on the blue bars. Okay, so what you do, you select this blue bar first. You select all the blue bars all together. Here you can see all the blue bars are selected, that is the drug A. Now you go to this plus sign, this chart element sign. Now go to this error bar, increase the option and go to more options. Okay, so here in more options you can see this direction is both, so the bar will appear in top and below. No need to change it here, just directly go to the custom. Okay, so below there is the custom. Now in custom you will find a pop-up that is specify value. Okay, it is asking for value specification. So what you do, you click on this. Click it. Now positive error value you need and a negative error value. So what you do, you just click on the positive error value first here. Click it here and select this one. This is for the drug A, right? So you select the standard error of drug A in the positive bar. Now coming to the negative error value, you select the same thing as well. Now you have selected this standard error of the drug A in both positive and negative error value. Positive is that the error bar which will appear above the bar, above the concentration bar that you have made, and the negative is below that one. Okay, so don't get confused. So you have selected this one. Now press OK. Cancel this. Now let us see. See, the error bars have appeared on each of the bars. Okay, and all the error bars are different in sizes. Right. So this is how you give error bars on the top of these bars. Okay, so this is highly used in research purpose. Similarly, we'll do it for drug B also. So what you need to do, same process. You select these bars first of the drug B. Go to this addition. Go to the error bar. Click on the triangle on the right side. Go to more options. Okay. Don't change anything. Just directly come to the custom. So here again you will get the specify value. Click it. In the positive value section, select the standard error of the drug B. Again in negative error value section, select the standard error. The same standard error, the drug B. Okay. Now press OK. Now you see there are error bars on the top of this drug B. Okay. On the drug B bars, on the top of this drug B bars, and all the standard error bars are different in sizes. Okay, that means all of them have different standard error, which is technically right. Okay, so this is how you put a standard error on top of each of the bars of your graph. Okay, so hope you understood how to put an error bar using the Excel sheet. If you have any queries related to this, please feel free to comment below.